Welcome to The Bottom Line Up Front, the podcast that cuts through the noise to deliver distilled insights from today's most important technical webinars, presentations, and demonstrations. Designed for federal and military IT leaders, each episode breaks down complex technologies into mission-ready takeaways so you get the key points fast. Whether it's cybersecurity, cloud architecture, or emerging defense technologies, we highlight what matters most and how trusted integrators like ATP Gov can help implement and operationalize these solutions across your agency or command. No fluff, no filler, just the bottom line up front. AI isn't just in your data center anymore. It's at the edge, which includes bases, field sites, clinics, depots, and embassies. That means more data created outside the enclave, new latency choke points, and encrypted traffic you can't see, but you still have to control. Today, we're translating Arista's vendor talk into what it means for .gov and .mil networks, and how to implement a secure, observable SD-WAN and edge design that supports zero trust and mission speed. We'll break down what AI for networking versus networking for AI really means, and why zero trust at the edge is non-negotiable, and how to keep mission applications fast and secure without breaking the WAN. So let's talk about what is moving to the edge and why it matters. AI at the edge is changing traffic patterns. We're talking bursty, latency-sensitive, and often encrypted from the endpoint traffic, and that's blowing up the attack surface. Enterprises and the public sector are generating a majority of data at the edge. That includes clinics, retail-like field sites, and logistics facilities. Moving all of it back to centralized clouds adds latency and cost, and comms often must be local for near-zero latency decisions. Edge sites often have disconnected, intermittent, or limited links, and their architectures must fail secure and preserve POAM and ATO controls during outages. This particular use case is moving from counting dwell time to reading posture sentiment in .gov and .mil networks, which translates to force protection video analytics, flight line safety, warehouse automation, and telemedicine triage, all requiring low latency inference on site. So let's dive a little deeper into AI for networking versus networking for AI. When thinking about AI for networking, Arista suggests that embedding GenAI and NLP assistance into your network platform allows you to troubleshoot faster and surface root cause insights. On the other hand, networking for AI is all about designing the network so that AI apps perform. They're right-sized for symmetrical bandwidth, because uplink matters now more than ever, for low latency, cost-aware pathing, and manageable operations at scale. So if you're looking for a mission tie-in, think Nipper and Sipper enclaves exchanging large ISR or maintenance data sets to local inference clusters. You need quality of service and policy that treat AI flows like priority traffic. And what that really means is yesterday's WAN sized for big downloads and small uploads. Today's AI flips that. Users upload large documents and media, and models return concise results. So you have to plan for symmetry and bursty flows. But there is a problem here, however, that we need to address head-on. Nearly all AI app traffic is encrypted from the endpoint. Privacy does not equal security. You still need classification, categorization, and behavior to enforce policy without full payload inspection. So what do the experts at Arista suggest we do? Infer application categories from metadata and behaviors, and then apply granular policies for quality of service, link steering, and segmentation. They also suggest using smart defaults for critical classes, that being voice and video, and extending this to AI traffic classes as well. Thereby, if and when you decrypt, you do so in line with policy and compliance, focusing on high-risk paths, prompt injection detections, and API inspection for agent frameworks. What they're really trying to say here is you can't secure what you can't even label. So start with accurate AI traffic identification and category-based policies, even when you can't see inside the packets. That said, is it possible to have zero trust at the edge? We believe so, and the Arista team called out a baseline of how to achieve this in their session. It requires an adoption of a fully documented zero trust network architecture. That's the who, what device, from where, to which resource. This also means firewalling with an integrated IDS and IPS and tight policy enforcement at the SD-WAN edge. So how do you achieve this in your environment? The first step is to map to the CISA Zero Trust Maturity Model pillars, focusing on a zero trust strategy specifically for the WAN edge. This includes user and app identity, microsegmentation, and continuous monitoring. The next step is to ensure policies remain in effect in air-gapped, hybrid, and multi-cloud scenarios, which is common across the DoD and IC. But for other agencies, it might seem overwhelming. But policy mapping is the most important step here. Like other network vendors in this space, some of which we've touched on in previous podcast episodes, Arista has also adopted a Model Context Protocol, or MCP, along with Agentic AI augmentation. Like we've mentioned before, there are risks to this strategy, those being agent hijacking, dormant command triggers, code execution risks, and tool injection from dubious open source MCP tools. What we really need here is agent-to-agent mapping, API call inspection with decryption per policy, and end-to-end visibility from LLM prompts to data resources. That means you have to treat AI agents like active principals in your network. You need audit trails and controls as if they were users, because operationally they are. And at this point, it's important to take a step back and look at this as a mission-focused systems integrator or a prime contractor. How would we enable secure AI at the networking edge? Well, here's what we would do. We would develop SD-WAN and edge architectures that deliver latency-aware pathing, quality of service for AI classes, and symmetrical bandwidth planning across CONUS and OCONUS networks. We're really talking about zero trust at the edge. That means developing a zero trust network architecture policy, microsegmentation, identity-aware routing, and encrypted traffic categorization integrations with your ICAM, as well as your SIM and your SOARs. We need to encrypt traffic visibility. We need to deploy behavioral classification, category-based policies, and selective decryption for high-risk agent and API flows. We also need to ensure that we implement Agentic AI and MCP guardrails. We need end-to-end agent telemetry, API governance, and MCP server hygiene aligned with federal controls. For example, SC7, AC-3 and 4, and the AU12 families. And no offense to the Arista team, but it's important that procurement and integration is divided across multiple ecosystems to avoid vendor lock. In the end, we're trying to align all of this to the CISA and DoD zero trust roadmaps. So what's the bottom line up front? The network edge is now the center of gravity for AI. You need to keep inference local to cut latency and protect sensitive data. Design your WANs around AI's bursty and symmetric patterns. Visibility drives control, even when encrypted. Use behavioral identification and category policies to prioritize AI apps and decrypt where policy and mission risks justify it. These days, zero trust at the edge is table stakes. We have to implement zero trust network architectures and firewalls and IDS and IPS all at the SD-WAN edges with tight identity to policy binding. We have to prepare now for Agentic and MCP. We have to build observability for agents, API inspections, and controls against confused deputy and injection tool risks. And finally, we need to operationalize with smart defaults. Pre-prioritize your AI classes. This is similar to legacy real-time traffic. And we also need quality of service and link steering. And then we can tune all of this per mission. So are you ready to see your edge the way your AI does? Then let's have a deeper conversation about deploying Arista's zero trust ready SD-WAN and edge AI that's actually observable even when traffic is encrypted. From QoS for AI workloads to Agentic AI and MCP safeguards, we want you to integrate the right tools, policies, and telemetry so your mission apps stay fast, resilient, and secure. Be sure to reach out to ATP Gov today at www.atpgov.com or email info@atpgov.com or check us out on social media on LinkedIn. Thanks for listening, and be sure to subscribe to The Bottom Line up front wherever you get your podcasts, and stay tuned for more distilled insights from the front lines of tech and national security. So until next time, stay secure, stay mission ready.